Well, I hope that wherever you were on New Year's Eve, you got to watch some fireworks and you looked up there and you thought, ah, chemistry. Yeah. Okay, well, several things you need to keep in mind as we're heading into the new year and we're getting ready for a test. So if you go to the website and you click here on Unit 3, atomic structure, you can find the review sheet for the test, and you can find even a key to help you through that. But right now, let's look at what you need to do and what you need to know in order to be successful on this little test that's coming up. So, can you compare and contrast protons, neutrons, and electrons and tell me things like where they are, what their charges are, how many there are in certain elements on the periodic table, and things like that? In other words, you should be able to look here and go, how many in carbon-12? Well, protons, it's carbon, and a carbon is atomic. That was looking pretty sloppy. See, I don't know where my first one disappeared to. There we go. Carbon, atomic number 6, so it must have 6 protons. Electrons, well, it's a neutral atom, so the positive charge has to be the same as the negative charge, meaning we have to have 6 electrons. Now this 12, remember, is the mass number, and that mass number is the mass of protons added to the mass of neutrons. So that means we must have 6 neutrons to make 6 and 6 add up to 12. So you should be able to answer those kind of questions. Where are they found? What are their mass? What are their charges? Number 2, you remember doing flame tests in lab? Well, there's a possibility that you would need to do a flame test for the test over this material. And so just make sure you understand that every element produces a characteristic spectra that's produced by excited electrons, and you can use those to identify an element. You can write the nuclear symbols for various species of isotopes. I wrote the nuclear symbol up here for carbon-12. So what you have to remember is that you have the symbol. I'm just going to put Z here for some kind of symbol. And actually, let me rephrase that. Let me put X here for some kind of symbol. And then we'll put the number here is sometimes written as a Z. That's why I changed this. That would be the atomic number. That's the number of protons. And of course you can find that because you have your periodic table with you. And you may have a periodic table that looks a little bit like this one, or it may look like something else. This periodic table, by the way, you can find right there on, where is the website? Right there. See where it says things you will need for Unit 3? The periodic table. If you click on that link, it will bring you to either this periodic table or a color version of it. Might be useful in case you've misplaced yours for the test. Okay, back to your review worksheet. So that's the atomic number, and the number here is the mass number, which is, of course, the protons added to the neutrons. So for uranium, we write the symbol. We look up on our periodic table and we go, where's uranium? Here it is, right down here. It's always hiding from me. Can you believe the uranium would go to that kind of trouble to make it so I couldn't see it? There it is, hiding off the bottom. Right here is uranium. Oh, that helped a lot. Well, number 92, right here, uranium. Get back to our worksheet. So down here, that's the atomic number, 92, and the mass is going to be 146 plus 92. So we've got to add the protons and neutrons together, and we get 238. So this is a isotope of uranium called uranium-238. 38. So that's the symbols of various isotopes. Can you write those? That's one thing you need to do for the test. Another thing you need to do for the test is calculating the average atomic mass of an element based on the masses of the different isotopes that make this element up, and of course also multiplied by their relative abundance. And so this is calculating average based on it's called a weighted average when we do it with your grade for this class. And I didn't have my calculator out before. Where is my calculator? Here it is. Might need my calculator as we're working on this problem. You will need your calculator. So remember, you just take some isotopes of this element, have this mass, a mass of 92. Well, it's 14.84%. So if we take this mass and we multiply it by 14.84 divided by 100, we're going to get, let's see, 92 times divided by 100, we're getting 13.65. And we do that for each species of this element, and we sum those together, and this total that's right here, this sum is the average atomic mass. Well, by looking at that average atomic mass and your periodic table, you should be able to decide, is this which of these elements are we representing here? Number 5, can you identify the location of all these different families on your periodic table? We'll go ahead and write them onto your periodic table. Alkali metals, alkaline earth metals, transition metals, and so on. Make sure you know where those are. And can you explain why elements in a particular group on the periodic table share similar properties? And you may remember that that has something to do with their electron dot structure, that all of these have one electron dot structure, all of these have two, all of these in this column have 3 electron dots, everything in this column has 4, everything here has 5, everything here has 6, everything in this group has 7, and everything in this group, once you get below helium, has 8 valence electrons in 8 electrons in the outer shell. So, and remember, we've also studied their electron configuration notation and things like that. So don't forget all of your stuff about writing electron configuration notation, orbital diagrams, and electron dot diagrams. Remember, electron configuration notations are things like 1s2, 2s2, 2p6, 3s2. And if you need to look back at that, go to the website and look at either ChemGuy's videos or some of mine if there happen to be some there. Orbital diagrams look at the orbitals, 1s, which could hold 2 electrons, 2s, which could hold 2 electrons, 2p, which has actually 3 orbitals and can hold up to 6 electrons. So you may want to review that and work with that within your group there this day, and you'll probably get those okay. Also keep in mind, this is some of these we've already looked at, but do you know the locations of and electron configurations of these families? The metals that we know specifically, the nonmetals, and we have 3 families there that you should know the names of. Of course, don't forget that you could be asked to do a conversion kind of problem at any time in your future. And so that's, remember, the kind of thing that if we have 1.2 kilograms, let's see if I can make that a little neater, 1.2 kilograms, and I want to convert that to grams, I have to set up the problem like this. 1.2 times a kilogram, and I'm going to use a conversion factor here, putting kilograms on the bottom and grams on the top. And I need to make sure I put the right numbers to go with this. I'm going to put one big thing, has a lot of little things. 1 kilogram has 1,000 grams, and check my units and do my multiplication and or division, and we've got the problem done. Okay, guys, go. Take it away. Well, don't take it away. Just get those problems done. See you later.